Then we got regression line. The regression line is a line that's put in the middle of a bunch of plotted points to try to figure out if there is a tendency, if there is correlation. Now, what is correlation? Correlation is a relationship between cause and effect. I'm sorry, correlation. A mutual relationship or connection between two or more things. Now, the biggest thing you got to realize, correlation does not mean causality. What's causality? And it's really easy to say. I drink too much wine, I have to pee. Remember Matrix Reloaded? Okay, if you ain't seen The Matrix, then I'm not the crazy one, you are. All right? It's one of the most famous movies ever made, Matrix and Matrix 2. If you've never seen it, yeah, I'm not the crazy one. There's a scene where the guy talks about, has anybody seen The Matrix Reloaded? Okay, you know what I'm talking about? They're in the French restaurant, and the guy talks about causality and correlation. That's what he's talking about. If there is cause and effect, you have causality. All right? The reason I said that, because I said something about I drink too much wine and I have to pee, and I had 3 or 4 people look like they were winged on a pickle. Y'all got to watch y'all's facial expressions, because you know when teachers are taught, we read facial expressions. All right? So, I'm not crazy. All right. Correlation. What's the difference between correlation? Well, there is a correlation between suicides in Maine and the number of Nicolas Cage films shown. Okay? Now, does one cause the other? Well, I'm not a Nicolas Cage fan, but no, there is no correlation. There is no causality between the number of suicides in Maine and the number of times a Nicolas Cage film is shown. Now, there may be a correlation, but there's no causality. How about the weight of a vehicle versus the gas mileage? Is there correlation? Yes. Is there causality? Yes. So you've got to understand the difference between causality and correlation. If you don't, then you're going to suck at it. Because you got to understand, just because you have correlation does not necessarily mean you have causality. Correlation coefficient is a number between -1 and +1. -1 to 0 is negative correlation, which corresponds with a negative slope. And then a positive correlation is between 0 and 1, and it correlates with a positive slope. Now, the reason you need to understand these things is because if you don't know the difference between these 5 definitions, then when I put the dots on the board and I put the line on the board and I do the regression and I do all this stuff, then you're going to be confused. Okay? Now, the correlation coefficient right here is called R. And they're going to give you a formula in the book, and you don't need to do it. The reason you don't need to do it is it's one of the most tedious formulas that I've ever used. Okay? I'm not even going to show you how to do it. But I will show you how to do it on your calculator and the Excel spreadsheet. Because I don't wish that tedious math on anybody. Okay? So, does anybody have any questions about causality, correlation, slope, anything like that? Hopefully you know the difference between them. Now, let's talk about points. Let's pull up the Excel spreadsheet. I've already got some pulled up, but I don't want to use those. So I'm going to do another one because those have a curve in it and I don't want to use those. Let's go with 1 and 2, 3, 4, 5, and then 4, 5, 6, 7, 8, and let's put those on a graph. Now, you see there's a straight line. So there's a correlation. It's a positive correlation. How do you find the relationship? Well, you right click on the points, go to add trend line, go over to linear. It's already picked linear because it is a linear line. You hit display equation and display R. So you need to write that down. If you don't have a calculator, you need to know how to do that. Now, there's the slope of the line. Y is equal to x plus 3. Our R squared is equal to 1. Now, what did I tell you the correlation coefficient was? R. So you have to take the square root of 1, which is 1. So R is equal to 1. You need to make that distinction on your Excel spreadsheet. So if you've got R squared right here, take the square root of that, and R is equal to 1. And that's your correlation coefficient. Now, what is the correlation coefficient? The correlation coefficient tells you if there is a fit. It doesn't tell you if there's causality. It tells you if there's a fit. What it does is it takes, well, let me give you another example. Let's say I have a bunch of points all over this place, like this. Like that. And there's my points, and it puts and there's several like this, and maybe one up here and one down here. There's my data plot, or my scatter plot. And it put the least regression curve right there. What is the least regression curve? Well, you take this guy, and you send a dash line there. And a dash line there. And you take this guy, you send a line there and there. You send a line there and there. Send a line there and there. And so on. Everybody see that? That's called the best fit. And the correlation coefficient tells you if this is more or less better than the fit here. Right there. Okay? And mathematically, it tells you if it's the best fit. That's all it does. Okay? If it comes out negative, that means you've got a line that goes negative slope. Comes out positive, you got one that's positive. If it's closer to 1, that means it's a better fit. If it's closer to 0, that means it's not as good as fit. Remember, what is the slope of a horizontal line? 0. The slope of a horizontal line is 0. So the closer you get to 0, whether it be -1 to 0 or +1 to 0, the closer you get to 0, you're getting a slope of what? 0. So you're getting close to a horizontal line. So that's where the correlation coefficient does coincide with the slope. Okay? That's about the only thing that coincides. What about causality? Causality, you have to look at the data and see if it supports. Now that's where, in English you've got context clues. You don't know the definition of a word if it's sitting by itself. You got to have the context clues with the sentence to tell you what the word means. Okay? If it has double meanings. In this case, you've got to look at the data and you say, okay, well, there's a correlation between, Nicolas Cage films and suicide rates. But then you have to look and see, well, they have really something to do with each other. And that's where the causality comes in. And you have to, think. All right? So, let's go over a couple of things. Let's go back to the first one. Let's go back here. And I want to talk about the slope. M is equal to delta y over what? Delta x, which the old formula, y sub 2 minus y sub 1 over what? X sub 2 minus x sub 1. Now these questions are going to be asked. This is your algebra, so you need to remember this. So write that down. Remember M is equal to that. You also got to remember your point slope equation. Y minus y sub 1 is equal to M times x minus x sub 1. And you've got to remember how to use your calculator with stat, edit, where you put it in your Excel spreadsheet, and stat, calculate. And there is something, I looked it up and I forgot it. But if you want to add those R coefficient to your linear regression, you have to go to catalog and you have to look up, remember, I'll have to Google it while y'all are working on the problem. I'm going to Google it and find it. You have to add it, and all of your calculators will put out the R if it's not putting it out. So I'll find that out because I Googled it, because I had to Google it for a student last week, and I forgot to tell y'all. But anyway, so you got to do all that. So all this is kind of a review over your algebra. Also remember, I'm not going to make you do the correlation coefficient by hand. I'm not going to do that because that's nothing but punishment. So So if you got one in your homework, just do it in your calculator or do it by the Excel spreadsheet. Okay? All right. So let's look at one. I have no idea what they look like, but we can go to the homework and see. Let's go. There we go. 4.1, right? Study plan. And I'll pull out a couple of problems that I would put on a test. I sure as heck wouldn't do A through D. I'm not going to do one like that. Oh well, to heck with it. I'll just use this data. How about that? We'll do what I want to with it. All right, so open it up in the Excel spreadsheet. There it is. And go ahead and do an insert. All right, you've got a data plot right there. Now, first thing you do is say, well, what do I do? Well, you right click on it. Add trend line. It's going to automatically pick up that it's linear. And then you go down here and you put display, put all three of them. Oops, not that one. There we go. And move this over here. And there's your line. Now somebody take the square root of r squared for me, 0.9425, and therefore you can find the r. Now the old way of doing it was to take 2 points. Before you knew about regression, before you knew about all that stuff, is to take 2 points and find the what? Slope and the y-intercept. So let's take this point read from left to right. So 3,000, 22, and 2690, comma 26. Say again? Oh, thank you. I suck. 3,000, there we go. And that's x of 1, y sub 1, x of 2, y sub 2. 26 minus 22 over 2690 minus 3,000. And 26 minus 22 is what? 4. And what's 2690 minus 3,000? Negative 10? No, I'm sorry, not negative 10. 310, right? Negative 310. And that's going to be what? 155. So 2 over 155. Negative 2 over 155. And somebody give me that decimal. Negative what? What's 2 divided by 155? 0.01. Does it match? Almost. You will not get the correct answer versus a calculator on the Excel spreadsheet. The only way you will get that is to actually do the least squares regression, which is even more tedious than the correlation coefficient. All right? So you better thank your lucky stars that you've got a calculator and you've got an Excel spreadsheet, because you do not want to do the math that's involved with finding the least squares regression. Now, what if you want to find the line? Well, you got a point and the slope. Plug it into what? Point slope equation, Hubert. That's right, class. Oh, that's x. Y minus 22 is equal to negative 0.01x minus, somebody take 0.01 and multiply it by 3,000. What do you get? 30. Yeah. And y is equal to negative 0.01x, and 30 plus 22 is what? 52. There's my equation of the line, and the regression is negative y is equal to negative 0.01x plus 43. So you see there is a little bit of a difference. Now, does that matter? Oh yes, especially in a business sense or a probability sense. If you use extrapolation or interpolation to extend that line, well, what is extrapolation and interpolation? Extrapolation, and I don't know how to spell it, but I'm going to do the best I can because I'm not perfect. I think that's right. And interpolation. Can anybody tell me the difference between the two? Look at the first 3 letters. Outside and inside. Good. With extrapolation, you're predicting by extending. Okay? You're extrapolating by extending the line. You're predicting. In other words, I'm going to take this line and in whatever this is, I don't know what this is, weight 15 pounds or whatever. Or that'd be what, 15,000? I don't know. Yeah. Or this is the weight right here. This is the weight and this is the miles per gallon. So at 15 miles per gallon, I'm pretty much talking about 4,200 pounds. So I'm extrapolating. I'm extending that line to predict a number. Where interpolation is finding a number within the line that you don't know. There's no point right here, is there? Is there any point in this area? Blue point? No. So what about a 3,200 pound car? A 3,200 pound car would be about what? 22 miles to the gallon. That's interpolated. It's inside the line. I didn't extend. That's the difference between the two. You would be surprised at how many people take a standardized test and they get interpolation and extrapolation, and they don't know the difference between the two. That's the difference between the two. Extrapolation, you predict by extending the line. Interpolation, you predict inside the line. Okay? And like I say, this is just a rundown of stuff that you probably already know, but I have to make sure that everybody knows it before we move on to probability. Okay? And that's probably the things they're going to ask you. I don't know what they're going to ask you on these problems, but that's it, basically. Now, let's talk about the calculator. When you pull up your calculator, I'm going to try to find that thing that you add. Does anybody know it? Can't remember. For some reason, I just can't remember it. But you go under catalog. I'll find it. Just give me a second. And you're welcome. I don't mind doing it. Adding R to TI, and the one I see it a lot on is the TI-83. Diagnostic. Okay, so you take your handy dandy calculator, and you go to catalog. Where is it? Second and then 0, isn't it? And go down to diagnostic and make sure it's turned on. And I think once you turn it on, it stays on, don't it? I don't know. There. And hit on. And enter. Okay, and once you do that, now when you type in stat, edit, and I'm going to type in 5, 6, 7, 8, 9, 10, and then I'm going to type in a bunch of RA numbers, 100, 150, 250, 100, 300, and 500. And now go to stat, calculate, and go down to linear regression, enter, and type in L1, comma, L2, and hit enter, and you feel good about yourself. There you go. So everybody should have a 0.8 correlation. And that's, now, does this say that there's causality? No. You have to look at the data, and that's where you get into the probability and the statistics. And yes, if there's people dying at Westside High School after at fifth period, then there's something wrong with the food. Yes, there's causality. All right. Same thing with the gas mileage with the heavier car. Okay. You have to look at it and see what's going on. Okay. Question. Now, why do they call? And this is something I don't understand. For years, how many years have they been telling you that slope is equal to M? And then you get the statistics, and what slope is equal to what? A. I have no idea why they do that. If you want to just put an M there, that's fine. But Y is equal to MX plus B, I don't know why they changed it to A. But can you have other type lines? Yes. Look at here. All right, there's a curve. Now, you can try to put a least squares regression line here. That won't work. Why? Because it's a curve. So you have to click on the dot, format trend line, and go over here and hit what? Polynomial or logarithmic, depending on what it looks like. So that's where you have to depend on your algebra to know what the function looks like. You're not going to see a lot of those in your homework. You're just going to see mostly scatter plots. All right? So let me show you another example. And I'm just going to make it up. I'm not going to do any points. I'm just going to, because most of the problems that I do on these questions is I want you to be able to tell the difference between a positive correlation and a negative correlation. I want you to be able to tell no correlation. So I'll give you some scatter plots. Like that. Like that. And like that. So if you was to put a line here, where would it go? And what is that? It's negative correlation because it has a negative slope. Which way do we read? Left to right. So put your car there. And if you don't know what that car is going to do there, then you don't need to know anything. You just need to quit. What about here? Put a car there. What's it going to do? It's just going to sit there because M is equal to what? 0. So that's a 0 correlation. Car here. That's a positive correlation. So that's the type of question I'll give you. The other type of question I'll give you, we've already done. The other type of question would be giving you a set of points. And you find the slope and the equation. Okay? Now, there's some that I'm going to give you that you do by hand, like the one we did a while ago. Find 2 points. And then there's going to be some that I give you that you do on your calculator or the Excel spreadsheet where you find the least squares, the regression line. So that's by hand. I'm going to put a point here and a point here, and I'm going to tell you those points 1, 2, 4, 8. And then you do the math. And then by calculator, or how you spell Excel? Is it CL? Is that right? Or is it EXEL? I don't know. Anyway, it puts a what? A least square regression line, and you give me y is equal to mx plus b, and then you give me r is equal to whatever. Okay? So you've got, I think it's EXEL, right? I think it is. So you've got by hand and by either the calculator or the Excel spreadsheet. Capiche? That's all I'm going to ask you in that section. I'm not going to spend a lot of time on that. Now, if you want to send me questions, that's good. All right, probability. Probability. Most of you have gotten behind somebody that goes 35 miles an hour for 100 miles. Has anybody ever gotten behind somebody like that? Especially on Wild Hog Road. You're going up to Pendleton, and you've got a class at 8 o'clock, and you get on Wild Hog Road at 15 till, you're going to get behind the Little Blue-Haired Ladies Club. There's going to be one on that road, I don't care. All right, and you're going to get up to Pendleton High School, and you're going to get right past Pendleton High School, and you're going to approach that red light, and you're going to say to yourself, I bet that car's going to turn left. And just as soon as you say that, what happens? Their blinker goes on, and they're going to turn left. Can you tell the future? No. Nobody can tell the future. Nobody. Nobody can tell the future. So if you ever meet somebody that says they can tell the future, what's the first thing you ask them?
Are you okay?
Huh?
Are you okay? What drugs are you taking?
Oh, y'all are stupid. What would I ask somebody? What would you ask somebody?
Lottery number.
Lottery numbers. First thing you ask. So you meet this woman that says she can tell the future. You say, okay, all I got you, one question. Give me the 6 lottery numbers for this Friday's Powerball lottery. Oh, but that's not oh, shut up. Okay? You cannot tell the future. All right? Nobody can tell the future. Now, could you go in, if you could time travel, yes, you could. Say Back to the Future 1, 2, and 3. Okay? If you have it, I ain't gonna say that. But that's the only way you can tell the future, is to go into the future and then what? Come back. That's the only way you can tell the future. Nobody can tell the future.
What would that mess up the future?
Now, you can take data. You can take observing. You can take experiments. And you can put a number from 0 to 1 on a what? On a prediction. Okay? And that's what you do. When you get behind a little old blue-haired ladies club on Wild Hog Road, and you get to go to high school, and you get about 200 feet from the red light, and you say that person's going to turn left. Well, first of all, if you're taking Wild Hog Road, are you going to Sandy Springs? No. If you're taking Wild Hog Road and you just got off the double bridges and you get behind somebody that's on Wild Hog Road, where are they going? They're going to Clemson or what? Pendleton. They're not going to Sandy Springs because they could have cut off somewhere else to go to Sandy Springs. So, mathematically, you know they're not going to Sandy Springs, so they're not going to turn right. And when you get to the end of Wild Hog Road, what directions do you have to choose from? It dead ends. You either go left or what? Right or left. There is no straight. Okay? So, mathematically, you know they're going to turn left. There's a 99% chance they're going to turn left because if they were going to Sandy Springs, Michelin, they would have turned at the doghouse. Okay? Now, what about observing? How many times have you gotten behind a person on Clemson Boulevard and they drive 5 miles an hour and you can't get in the other lane? And you predict that they're going to turn right because you're turning right. You do it because you've had experiences. Some of y'all are 18, 19 years old. You've had 3 or 4 years driving, and you get behind these people, and it seems like they got a radar in their car, and they know which way you're going. Okay? You cannot tell the future, but you're using that experience and those times that you've gotten behind these people, and you're putting not a number, but you're putting a guess on where they're going. Okay? Same thing with cattle. Okay? Some of y'all have no idea what I'm talking about, but when you have cattle and you work cattle, you got to get them into what's called a holding pen. And if I've got a 10-acre pasture and I want to get them in a half-acre lot, there's 2 gates that go into that 10-acre pasture. And I let them cows come in that 10-acre pasture and I leave one gate open. Will they go toward the gate, the holding pen, or will they go toward the open gate to get out into another pasture? They'll go to the gate that's open to go to another pasture. And I can predict that because I've fooled cows all my life. And they're going to find a way not to go where you want them to go. You can use this type of thinking with a lot of things, all right? But the main thing is that you are not telling the future. What you are doing is you are using data, observing. That's not right. Is that right? I guess it is. Observing and experience to put a number or a guess on a prediction. Capiche? Now, how do you do probability? Probability of an event happening. Probability of an event is equal to the number of times something happens over the number of times something what? Could happen. Now there's two types of probability. There is and I call it the Mayberry probability and the physical probability. I don't know what they call it in the book, and I really don't care. All right? The Mayberry probability is strictly mathematical. It's strictly math. If I asked you what is the probability of getting tails on a coin if you flip it, what's everybody in here going to say? 50% or 0.5, right? But what if I ask you to flip a coin 10 times, what will you tell me the probability is it's going to be? You're going to say 50%, but will you get 50%? No. So there is the mathematical probability, and then there is the physical probability. The mathematical probability is already calculated. You need to put that down. It's already calculated. The physical probability is what you actually do. Okay? So Mayberry, the reason I call it Mayberry is a modern day utopia. And I figured, perfection. So the mathematical is already calculated. You can't change it. You can't say, okay, I'm going to change the probability of a coin, being flipped to 0.45. You can't do that because the mathematical calculation is 1/2, which is 0.5. So the Mayberry probability is already calculated. And it's mathematically calculated. Whereas the physical probability, physical probability is what you observe or experiment with. And that is based on the large number rule. What is the large number rule? Well, back in about 5 or 6 years ago, they had a big piece written in one of the books, the Triola books, and it talked about these two guys at MIT. They took a roll of quarters. When they took the roll of quarters and they scanned each quarter, and they got a weight of each quarter. They micrometered each quarter. How many quarters are in a roll of quarters? It's 40, right? So they took these 40 and they put all that information into a computer and algorithmically generated the average quarter from those 10 quarters. And they took that quarter and they put all the measurements in that one quarter, the virtual quarter, and they wrote the program to flip that quarter so many times what the probability would be. Now, we said that the Mayberry probability of getting tails was 0.5, right? So, how many flips of that virtual average quarter that the MIT students did, how many flips did they have to flip in that virtual flipping algorithm? How many flips do you think they had to flip to get the 0.5 probability? So I want to take a guess.
2?
2. No.
Thousands.
No, not 1,000. I'm not going to tell you higher or lower because anybody want to take another guess besides 2? 2 out of 30 people?
Is it like an exact number or is it like
100,000. It took 100,000 virtual flips of that coin that they generated to get to 0.499995. Now, what does that mean? Now, this has to do with statistics and probability. Remember me telling you about the Michelin guy, the executive that threw out 5 tires and got fired? Okay? If you're going to put your neck on the line, now we're talking about in the future, when you got a job and you're bringing in a paycheck and all that good stuff, and you're being paid to do something, do you think you want to pull 5 tires, or are you going to pull 5,000? What does the large number rule say? You pull more. You pull as many as you can. Because you're putting your neck on the line, not only with statistics, but with probability. Always go with the large number. Let's say you've got money to do 50 surveys, okay? And you decide, well, I really want to do 25. Well, you suffer the consequences if you only do 25 and you got money to do 50. Or you just do 250, but you've got money to do 500. Just because you're what's that word? Lazy. Just because you're lazy, you think you're going to get by? No. One thing about mathematics, it's kind of like being pregnant. You either are or you what? You aren't. There is no gray area in mathematics. And if you're dealing with a presentation and you're doing mathematics, there is no gray area. Either you do it or you don't do it. And with large number rule, if you're you may be a nurse on 2 North, and your job is to count how many people died on 2 North the last 5 years. And you go in and you do all that math and then you project numbers. Your job may, depend on how well you do it. And if you're lazy and you think, oh, I just got this job and I'll just do it. As long as I come in every day, I'll keep my job. It don't work that way. Okay, so I'm just telling you that so you'll remember the large number rule. The large number rule says when you're dealing with statistics and mathematics and probability, the more, the what? The better. Okay? So, now, something else you have to do when you're talking about probability. Reading comprehension. Some of y'all will get problems wrong on a test because you can't what? Read, or you don't read. There's 2 different. All right? Now what I mean, everybody knows, CAT is cat. Y'all know how to read. All right? But it all depends on what the definition of is. What president said that? Oh, yeah, I'm sorry, that's history. Y'all wouldn't know anything about that. Anyway, that's what Bill Clinton said. It all depends on what your definition of is. What is he talking about? He's talking about comprehension of a word. All right? Was. Is there a difference between was and is? Yes. You've got to read the question. When you're talking about these questions versus statistics, you've got to read the question. The words that you're going to be looking for is and or. And means that you're going to do one thing, or means that you're going to do another thing. We'll get to that when we get to multiplication. All right? Something else. I asked this question on a test. I'm just going to write it. What is the probability of rolling a 7 on a die? Out of 30 people, 10 people got it wrong.
1 and 6, right?
Of football. Why did they get it wrong? Because they didn't what? They didn't think. How many numbers are on a die? 6. These are people that couldn't spell mom backwards too. I mean, they were really, really bad. Okay? The probability of rolling a 7 on a die is what? 0. What is the probability of having a king or drawing a king out of a deck of cards? Well, there's 2 or 3 things you have to know here. What's the 2 or 3 things that you have to know?
How many kings and
how many cards are in a deck, and what? How many kings are in the deck? If you don't know that, you're SOL. So there are some things you have to actually what? You have to read, and you have to know. So if you don't know anything about a deck of cards, you might want to go get some. Now I got them right here. We're not going to do it today because I don't feel like it. But that would be 4 over what?
52.
Okay, 4 over 52. All right, you have to know the difference between odd and even. What if I said the probability of pulling an even card? Well, what is a face card?
1 through 9.
Face card is 10. Okay, what is a ace? An ace is either what? A 1 or what? 11. And it will decide. It will say that in the question. All right. So if I tell you what is the probability of pulling a even card, well, let's say 2, 4, 6, 8, 10. How many is that? That's 5, right? 2, 4, 6, 8, 10. Then you got 4 face cards. That's 4 plus 5 is what? 9. How many suits you got? 4. 9 times 4 is what? 36. 36 over 52. Now, if you don't know any of that, then you need to go get you a deck of cards. Should you reduce that? Yes, always reduce. Okay? Now, what are these? These are mathematical. These are Mayberry probabilities. These are probabilities. None of you have a deck of cards. How do we get these? They're mathematical. They're already generated. They're already calculated. You just have to know what you're doing. Okay? Now, when y'all come back Monday, and hopefully I'll feel better, I'm going to pass out the cards, and I'm going to pass out, I hope y'all can handle this, right? Okay? I mean, I have people in here that don't have a notebook or a pencil or anything. I have 3 or 4 of y'all that's not even writing anything, so I don't know what's up with that. I guess y'all wrote the book, right? Did y'all write the book? No, y'all not gonna talk? Okay. Maybe y'all can teach the class since y'all know everything. Okay? Book. All right. The whole point is, come to class, y'all don't like bring a book and pencil, you know? Anyway. You need to know the things that you're going to be talking about. So I'm going to pass out the cards and I'm going to pass out the dice and y'all going to do some experiments. And hopefully some of y'all that's ever touched a deck of cards, you'll know what the deck of cards are. For those of you that don't know, you can pull up deck of cards Bible. Okay, I know I said Bible and some of y'all are going to call the ACLU and everything, but Bible, that's a word, okay? It's called a card Bible, deck of cards Bible, and it tells you the suits, it tells you the tricks, it tells you, face cards is in there, so you can Google deck of cards Bible, and it will tell you everything you need to know about a deck of cards. You might find some of that interesting, okay? What if I asked you, what is the probability of an even number on a die? Probability of an even number on a die. That's equal to what? 3 over what?
6.
Which is 0.5. Again, you have to know what a die is, and you have to read the question. Okay? So that's what we're going to be talking about Monday. Is 4.1. Somebody tell me which one is probability? Is that chapter 5? Because correlation is 4.1 and 4.2.
Yes.
5.1 is what we're talking about right now, okay? And we're going to talk about all of that come Monday, or whatever day, Tuesday, y'all come back. Any questions? All right, y'all get out of here. Have a good day. Have a good weekend. And I'll load the homework on the computer sometime today.